All right, well, welcome everybody to our monthly cybersecurity seminar series. This is the UCSF-Stanford CERSI and FDA Distinguished Speaker Series on cybersecurity for biomedical engineering. My name is Professor Kevin Fu from Northeastern University and the Archimedes Center for Healthcare and Medical Device Cybersecurity, and I'll be your moderator today. This seminar series, just a disclaimer, this seminar series does not represent official FDA policy or guidance, and the contents are those of the speakers and do not necessarily represent the official views of nor an endorsement by FDA, HHS, or the US government. This seminar is being recorded. Here's a little bit about my background as the moderator today, and also I'll be joined by Bill Arts as a co-moderator. So he and I will be in this fireside chat with David Brumley. And before we get started, I do want to just have a brief moment of silence. We lost Professor Ross Anderson last month, and he's worked with many of us for 20 years and more, working in the cybersecurity industry for decades. And literally wrote the textbook on security engineering. He passed away in March in his sleep. And he was a CERSI speaker early on in this seminar series. So just a moment of silence for having this loss of Ross Anderson and his many contributions. Well, you will be missed, Ross. A couple of announcements before we begin. FDA is hiring. If you are interested in a career in cybersecurity, you can contact diane.mitchell@fda.hhs.gov. So why are we here today? Just a reminder before we get started on our talk today, medical device manufacturers have been struggling with not just your run-of-the-mill hackers, but quite organized units of crime, from ransomware to various forms of malware. In response, the US government has been working hard behind the scenes for preparation and making sure manufacturers and healthcare delivery organizations are prepared for the inevitable cyber attacks. And of course, last month in the United States, we suffered what appears to be the largest ransomware attack in history, where a large healthcare billing provider has been down for weeks, or it could be measured in months now, due to ransomware. So why are we talking about the combination of cybersecurity and biomedical engineering? It's very difficult to separate the two anymore because of the pervasiveness of computing into the design of medical devices. And so you can see both from a policy perspective, things like the Patch Act and the Omnibus Bill, as well as regulatory guidance. So you could just see just a few weeks ago, FDA releasing its draft guidance on the famous Section 524B. This is the policy from FDA that is responding to the congressional mandate for software bills of material and other security measures being built into medical devices. There's also been the finalization of the FDA guidance on cybersecurity in medical devices, quality system considerations, and content of pre-market submissions. This long title can be basically translated into, hey, manufacturers, what do you need to do during pre-market if you'd like to get your medical device cleared for marketing in the United States for cybersecurity? How do we get cybersecurity built in pre-market? What are the engineering expectations you will have during a review? Everything from threat modeling to software bills of material to penetration testing with independent teams. We've had a large number of distinguished speakers. Last time we heard from Brian Mazanek from Asper, and today we're going to hear from Professor David Brumley. He is a full professor at CMU, Carnegie Mellon University in Pittsburgh, and he's also the CEO of For All Secure. Today's fireside chat is going to be on testing like a hacker. And it's really great to have David on the program. I've known David for I think it's been 20 plus years. And he's done some amazing research. And he's let me just say he's been quite humble, and so I want to do some bragging on his behalf. He's published some of the most well-cited academic research papers in the technical cybersecurity community. In fact, he won the Test of Time Award at a conference called Security, which is one of the most selective conferences. Usually only 15 to 20% of the papers get accepted for presentation. And his Test of Time Award on remote timing attacks being practical represented a 10-year horizon of the best papers at this conference. So he's extremely well regarded in the academic community. He's also been part of the team that won the DARPA Grand Challenge Award. This is effectively the penetration testing award. And I believe that was a $1 or $2 million award or a prize. I can't quite remember. But it was a large award. And so if you want to talk about penetration testing and see, I always say, do it with someone who's been successful before. I can't think of something more successful at this. So David, I'm going to turn the screen sharing over to you. And again, welcome to the program.
Well, thanks for having me, Kevin. I'm excited to be here today and to talk to this community about cybersecurity. I'm going to share some slides, but really this presentation is going to be in 3 parts. I'm going to provide a little bit of context about hacking in general. What do hackers do? I'm going to talk about how you hack a car because, well, it's kind of cool to hack a car. And then I'm going to talk about interest in medical devices. And then I want to have a discussion with you, Kevin, and the audience about what does it mean to break into systems, because I absolutely love this topic. So I love hacking. It's kind of an odd thing to say. A lot of people think of hacking as being a criminal, but I don't. There's definitely people who have criminal intent who break into computer systems, but really hacking is about being able to win this game of offense and defense, being able to show that you can defend your own infrastructure, your own devices, your own software, your own systems, and also showing that you can break into other people, that they're not doing a good job. It's just like amazing. So I want to start off actually by introducing who I think actually is one of the world's best hackers. His name's George Hotz. George can just do amazing things. And to give you an idea of what he did and why he's so good, I want to talk about one of his very first hacks. When the Apple iPhone first came out, it was restricted so it would only work with certain carriers. George, when he was only 19 years old, was able to take an iPhone and free it from that restriction so that he could own the phone and connect it to any service provider he wanted. That's what hacking is about. It's about enabling freedom in systems, being able to bend them to your will. And in this case, it was a lockdown device that a manufacturer was really trying to keep into a closed ecosystem. And he showed that by examining how they worked, he was able to figure out how to open it up to a much larger set of possibilities. And he went on to hack the PlayStation, to hack Android, to hack Chrome. And right now, he's looking at hacking cars. How do you go into cars and add, for example, aftermarket automotive? It's just amazing what people like George can do. And when you look at really what's behind the method to their madness, it's about combining skills with creativity to find novel solutions. I love this picture of this Rube Goldberg device on the left, because there's this idea that, it's very easy to pick up a napkin when you're eating soup, but there's also very unusual machines that you can build that do the same thing. And here, when the person lifts the spoon, it pulls a string, and that string pulls down a cracker, which causes a parrot to take off. Eventually, the big chain of reactions, wiping the person's mouth. This really is what the essence of hacking is. It's about, of course, having high-tech capabilities, but it's unleashing those in very creative ways to go about new and novel projects and to do things that, quite honestly, people didn't think that you could do before. So I want to give a little bit of an analogy. If someone gives you a maze and says, solve it, here's a maze and says, solve it. And for example, they even show you a solution. Often this can just narrow your attention on there's only one way to approach a problem. This is one of the unusual things about hackers, is being able to free your mind to look for alternate solutions to the same problem. For example, when you're looking at this, some of you may have not have noticed that there's a completely separate path through this maze that you could take that's completely valid. And I tell you, that's not the only one. Why even go through the maze at all? Why not just go around the maze? And what hacking really is about is exploring the solution state and bringing your creativity to find these unexpected ways to make systems do things that are just completely novel. Kevin, you talked about my talk on RSA timing attacks. And really the funny thing is it does illustrate a bit the hacker mentality. If my wife asked me, do I look fat in these pants? And I pause, I've kind of given away the answer. There's a lot of information out there, and there's a lot of different ways to go deduce that information. And even something as simple as a pause can reveal more than you want. This intuition was actually what led to that RSA break that you mentioned, Kevin, where essentially at a high level, the amount of time it takes to decrypt something depended upon what the value of your key was. So if you had picked a secret key that was 1, it maybe took 1 second to decrypt. Pick a key 2 at 2 seconds to decrypt, and so on. Now, it wasn't quite this obvious. It required a lot of thinking and a lot of careful timing. It wasn't, a full second for key 1, a full second for key 2. But it's the same idea of taking this idea that we can look at a crypto system that has a mathematical guarantee of security and then say that mathematical guarantee doesn't really talk about the implementation. How can I look at that implementation and find a novel solution to make it do something unexpected? And the case just happened to be timing. So hacking is really about creativity. And I want to show you one of the things that I think is really cool where people apply these concepts to do really cool things. And I'm going to do it in the context of a contest called Pwn to Own. Pwn is hacker speak to being able to take over a machine. And once a year, there's a contest called Pwn to Own, hosted in Vancouver, where vendors will put up the latest and greatest version of their devices and offer hackers a prize if they can break it. So you have companies like Google that push out their latest browser and Apple that push out their latest iPhone. And a few years ago, Tesla put up a brand new Tesla and said, hey, as our latest software, it's as secure as we can make it. If you can hack it, you can win it. 2 amazing hackers, Benedict and Ralph Philippe, took on the challenge. And the way they went about it, I want to walk through now because there's many parallels to how you think about medical device security. So the first thing these 2 did is they mapped the connectivity of the Tesla. And if you look at a Tesla out there, they're all running a Wi-Fi access point. But of course, if you're an attacker, you don't have the password for that. So what do? You have no credentials. Well, the 2 hackers figured out that the firmware on the Tesla had that password hard-coded. And so by reverse engineering that firmware, they were able to figure out what the credentials were to connect to any Tesla. It turned out actually kind of a funny thing after the case, where they went through all this work to manually reverse engineer the software, and Tesla had accidentally copied it to Twitter. And so you could actually just look at Twitter, and if you knew what you were looking for, there was a master key there where you could connect to Teslas. The second thing they did is they mapped the software stack. So having just that initial network access doesn't give you full ownership of the car. You have to be able to take over the system. And to do that, you have to figure out where new vulnerabilities exist. And this is actually the architecture of a modern car. A modern car has a Wi-Fi connection, an LTE connection, and these are connected through the infotainment system. There's an antenna, a cellular modem, and it connects to that screen in your car. That screen in your car runs a connection manager. In this particular case, it was called Conman. It runs Linux kernels. It has NVIDIA hardware for displaying in real-time updates. And then this is all connected to the back end of the car. On the back end of the car, you have electronic control units. These are smaller, weaker computers that do things like manage your air brakes and manage your braking system and do things like make sure if you're in a crash that your doors unlock. But if you look at this diagram, you also see an approach through the Tesla to those highly critical systems. If you can break into infotainment, once you have access to the Wi-Fi station, you can then connect via Ethernet to what's called the gateway device, and this is a small firewall on your car, and then get access to those critical sections. Now, when Benedict and Ralph were looking at this, they really focused in on that connection manager. That's a piece of software that really has to be right. And what had happened is Tesla had pulled this software from open source, put it on the Tesla, and they just ran it as is. As they started looking at this piece of software, this connection manager running in this critical domain, they applied what I call the hacker protocol to finding a brand new vulnerability. And this actually is something that George talked to me about when he was a student at CMU. I asked him, George, how do you find all these brand new 0 days? How do you go about looking at an iPhone that has a team of engineers looking at security and then figure out when you're a teenager how to hack it? Same thing with Google Chrome. How do you do that? And he said, really, it's quite simple. What I do is I look at the software and I look for what's been tested. And I skip those. Happy paths behave as normal. They do what they're supposed to. Instead, what I go is I go look for untested code or under-tested code. And then I start writing test cases for it. And in some ways, all a test case is that triggers a vulnerability is something that's proving that it's present. And in fact, that's what you turn into an exploit. So the process is you look for those things that are well tested, you identify the stuff that hasn't been well tested, and then you just start testing it with the idea that as soon as you find a vulnerability, you've essentially created an exploit in the process. This is what really all the best hackers do. This is how you go find those 0 days in the iPhone. This is how you find it in a Tesla. And so at the end of the day, what Benedict and the other researcher were able to do is hack this Tesla through a drone. This is a picture from Pwn to Own 2021. And what you see is a drone at the top and a car getting hacked at the bottom. And actually the way this works is the drone impersonates a Tesla service station. That's the hard-coded password that Teslas had in them. So when a Tesla came up to a Tesla service station, it would automatically attach. That drone can forge that ID, have the car connect. Once the car attaches to the drone sends a malicious response to the car. Essentially, this is in the connection manager. This is what's called DHCP. The car is asking for an internet address from the drone, and the drone sends a malicious reply that triggers a buffer overflow in this open source piece of software. Once that connection manager is exploited, the drone can launch additional attacks that navigate through the car software stack to eventually open the doors. Pretty cool, right? I mean, you can fly by a car and hack it. Who would have thought? So hacking is about creativity. It's looking for those things that have been under-tested or unwell tested, things that haven't been tested with this hacker mindset. And it's been something I've been working on for a long time. In 2020, I was actually diagnosed with head and neck cancer. And at that time, actually, healthcare security became very personal to me. You can see here in my picture right after surgery, where I have staples in my neck, and it probably took me another 4 months to be able to eat and swallow by myself. And as I was going through this process, I started to notice all the connected devices in healthcare, all those things, Kevin, that you've been talking about for over a decade, and how those impact my security. This is a picture of just all the devices that I personally have ran into in the course of my treatment. And there's even more. On the top right, there was the Da Vinci robot that was used to do that surgery. There is radiation machines that were used here in the middle to, after I had the surgery, give me 5 weeks of daily radiation. And then when that cancer metastasized in my lungs, do it once again. I get CT scans every 3 months, PET scans, and MRIs, and all these devices are connected to the network. And one of the things that kind of scares me in this world is the medical community hasn't really embraced this hacker mindset. Tesla and Google go out and tell the best hackers, if you can break into this device, we'll give you money. And the reason for that is you're showing us where our weakness is that we can patch it. We can do that before criminals take advantage of those same flaws. And we haven't really seen that same sort of approach in the community. It's been a lot more closed. And I remember back to one of my early jobs where I worked at a place that was connected to a hospital, actually. And I remember once getting called over doing IT security because the hospital CT scan machine was compromised. The reason it was compromised is because someone had forgotten to put a password on it. The manufacturer had. And then I worked with them and said, hey, this is the problem. This is how the hacker broke in. And the device manufacturers came back to me and said, hey, you can't go just change the password or even update the software because it's an approved medical device. They kind of invoked this FDA name. I'm probably sure in vain. I don't think this is really how things work, but that's certainly what were they doing. If you fast forward to today and just look at the exponential growth of these devices, What's become more and more apparent is we have to look at the security of them, and we have to get into a very rapid update cycle, at least as rapid as we see on cars and computers and everything else, because behind all of these machines are that same software stack that's on the Tesla that's hackers can get at. It just hasn't been tested yet. One of the other things that actually boggled my mind, and I was talking even to a reporter recently about this, is when we go look at how medical devices are certified today, it follows very similarly to how automotive works. And the thing that was weird is safety is not security. You can go up to someone in automotive and they can tell you, hey, this car is completely safe. And then you can show them how to hack it, and they have not told a lie. And the reason for that is safety standards are different than security standards. Meeting a safety requirement is about making sure the machine has redundancies and those happy paths, those intended behaviors have been checked. We see things like system verification testing phase, which really is just checking to make sure the machine does what it's supposed to do in the intended operation. But that's not what hackers do. Hackers do the equivalent of looking for those weird cases that no one expected, learning new information that you wouldn't have thought could have been revealed, like asking you if your wife asked you, do I look fat in these pants? And so as I was looking at this, I was really excited to see that the FDA last year issued new cybersecurity guidance. And I've been working with vendors to try to build up a reference secure software development pipeline that would meet these. Requirements like the FDA put out are enormously important. They set really the final idea of what you should have, but they don't really go into the how to do it. It's about outcomes, not process. But if there's one thing that I've learned in all my experience hacking, it's details matter. And so the idea behind this is to build an open source secure reference pipeline that anyone can clone that actually meets this guidance, that gets at the how. Now, of course, vendors can create their own pipelines, but this would give a starting point to get that rapid feedback cycle that we need. So those are all the slides I had. I wanted to tell you what I think hacking is and why it excites me. How people go after sophisticated systems like cars that have similar standards in healthcare, and then looking at what I think, how these can be applied within healthcare and what the next steps would be. I'd be excited to hear questions.
Thank you, David, and thanks for sharing your personal journey as well. I know that must be difficult. For those on the call, you're welcome to submit questions for consideration in the Q&A button down at the bottom for this rare opportunity to talk with a real expert in penetration testing and other forms of testing, or we could even talk about good old RSA analysis. But I'll begin with a question. On one of your earlier slides, you talked about, well, what's the best way with the hacker mindset to sort of find potential vulnerabilities, and you talked about using under-tested code. So explain to us why this is not a catch-22, or how does this work? Because how do you identify untested code? There's not, is there a label saying I haven't tested this? Probably not. So maybe you could tell us a little bit about what that looks like, both as a manufacturer of software and hardware, but also as the penetration tester.
Yeah, sure. I mean, that's a good question. So when people like George are looking at things like Google Chrome, source code and tests are available. So they can go look and see what was tested. The second thing is, if you don't have code, you go and look at what normal expected behavior is. You run through those scenarios and you mark that code as those are the things that are likely. And then what you start looking for are the exceptions, the if-thens, if you will, where the if is the happy path and the then is the bad path that was untested. And then you start focusing on that. And if you want to bring in more heuristics, you can start looking at the complicated code, because people know more complicated code is more likely to have vulnerabilities. I'd also say, like, I use this kind of high level look for the under-tested or untested code. I want to be a little bit careful here, because sometimes people will come and say, hey, we have 100% code coverage, and therefore we can't have vulnerabilities. And that's not quite right, because when we think about code, we have to think not just about, did I execute that path once? We also have to think about, did we take cases where, for example, we executed a loop a whole bunch of times as opposed to just once? And so I did put kind of this simplification on it. of what it meant to be under tested, but essentially that's what people do is they go look for what hasn't been in the unit test or what they think would be outside of the validation tests. And they would look for those exceptional conditions, either by executing code that's already been tested more times than normal or things that just haven't been tested at all.
Got it. We've got a bunch of questions queued up, but I have one follow-up before we turn to Bill, who has the first question. Is this all manual, or what's the state of the art in tools? Are these penetration testers just typing on a keyboard, or is it AI driven? You know, what give us a picture of what is the state of the art, not only for the sort of the good hacker, you know, the one who's being paid to do the testing versus the real adversary, you know, the nation state backed groups. What do we know and what do we imagine in terms of tools?
Yeah, the state of tools is quite different between offense and defense, and I find it a bit alarming. So let me first talk about people who do it right. Actually, Google has a pretty good software development process. As part of software development, what they do is they first make sure they don't have outdated components. This is the basic health of software, making sure you don't have updated software. The second thing they do, though, is they run dynamic analysis. They run a process called fuzzing. And the idea of fuzzing is that you're trying to elicit unexpected behaviors from software. And there's different sophistication levels of this. At the early stages, this was just randomized testing. And what was surprising actually to the community is how many new problems you found just using random inputs. But it's become crazy sophisticated compared to that. At CMU, we developed techniques based on formal analysis to do this sort of thing, where we could take a program, run it, figure out what conditions weren't executed, and mathematically model those. These are the sorts of techniques that attackers use to find exploitable bugs. When you go look at the typical, it's called the AST, the
Spec syntax tree or
application security testing Gartner group.
Okay, different.
They'll talk about things like static analysis. Hackers don't use those. I've never once seen a hacker find a 0-day by going and running a SAST tool. What I have seen them basically exclusively use is either manual analysis or fuzzing or something like symbolic execution. So yeah, the tools are different.
Okay, and these are on binaries, not source code, I assume.
I mean, hackers will do whatever they can. If they have binaries, they'll just look at the binaries. When we look at national security, one of my expertise is looking at weapon systems, and you know, it's something that fell off a truck somewhere. We don't get source code. But when you do have source code, it's much easier. And as defenders and as a healthcare community, we have to be looking at our vendors to put these into source code because it's just more efficient to do so.
Great. Well, let's turn. Bill Arts has his hand raised for a question. So, Bill, why don't you go ahead?
Actually, I saw this question that was kind of on the list of questions. It says, when we talk about medical device security, people often ask, what are the unique challenges in improving the security of medical devices that make it different from other things? And David, you talked a little bit about the fact that the connectivity is going up on devices, but what else can you think about in terms of medical devices and in healthcare in general that make this challenge unique?
Yeah, I actually use automotive here because I think it's a similar parallel. So when we talk about medical devices, we're talking about a broad swath of software devices used in different purposes. And as you know, there's different safety levels and security levels applied to these. Something that's going to be implanted in a person may have a level 4 safety requirement, while something that's just used to display images may have a safety level 1. And so I think the thing that makes medical device security interesting is you have a broader array of things to look at. You have to be looking at doing really deep validation and verification of those things that require the highest level of scrutiny. But I also don't want people to forget that with that comes increased connectivity. And so what attackers will do is they'll look for the easiest access point, which may be like a level 1. It may be on the surgery device I just showed you. It could be that Windows system that people are used to looking at results. And from there, pivot in to the more critical system. And so I think medical devices, there's some unique challenges because you're working a lot more in the embedded domain and you're working a lot more tightly with regulation. Anytime you add regulation, you're adding necessary hoops, but they are add complexity. But I also don't want us to forget that that connectivity means that you can't look at them in isolation.
Right. Well, let's see. We've got a bunch of questions. I see one from Adam Shostak, one of our mutual colleagues. You can see David smiling there. So Adam, of course, teaches on threat modeling, and he'll be teaching a course with Archimedes in just a couple weeks. But he asks, hey, your team did an amazing job at automating testing on the DARPA Cyber Grand Challenge. And his question is, how do you think about that past work you've done in relation to thinking like a hacker? And I think Adam is probably getting toward the threat modeling mindset. Does the Grand Challenge code think? I'm not sure what he means by that, the think part, but maybe whether it's sentient. But what are some of your thoughts on response to this question?
Well, I think in academia, there's a broad range of opinions on whether like the most advanced LLMs are thinking or not. I tend to think of them as just statistical patterns. So no, I don't think of them as thinking. What we did in the Cyber Grand Challenge is we used hardcore program analysis to prove zero-day vulnerabilities by generating exploits. We can call it AI because we were seeding over to a computer something people would manually do. Like we can call lane assist in a car an AI, but it's actually more of a control system. It's not thinking at all.
Mm-hmm.
I can also say some of the things that we did in the AI Cyber Challenge, which were really kind of cool. We had an entire strategy system. So for example, if you're really doing offense and defense, what you always want to do when you come up with an exploit is exploit the weakest. And the reason for that is not just to be mean, it's that if they detect it, well, the strongest will. The other problem that you have in these sorts of things is once you use an exploit, people can record it and use it against you. And so there's a little bit of like, if I exploit you, Kevin, then I've given you an exploit and then you can exploit Bill. How do I maximize my gains on this? And so we did have some stuff there that was kind of unique from a strategy standpoint, but I wouldn't call it thinking.
All right. Well, let's see. Switching gears, we have a question from Marty at Optum, and his is more about, I would say, ethics and legality. So he's asking, what are the legal constraints associated with ethical hacking of medical devices? I'm sure you've got some stories there. And what are some of the best practices to protect an ethical hacker from, legal litigation effects during the testing phase, as well as the ethical disclosure of vulnerabilities? I'm sure we could have a whole hour on this, but any high-level thoughts, especially keeping in mind there are a lot of the participants on the call today. Some are from healthcare delivery organizations, some are biomedical engineering academics, but there's also quite a large contingent of medical device manufacturers, some of whom don't know how to work with an ethical hacker, and even to know, are they an ethical hacker, and what does that even mean to be an ethical hacker? Anyhow, so many things we could talk about.
That's a really broad question. I think to keep a couple of things simple, the first rule I tell my students is never break a law. If you're breaking a law, you're not being ethical. That's just kind of a simplification of it. The way that this ends up manifesting inside a lot of the working with an ethical hacker is the manufacturers lay out bug bounties. And so it's up to the manufacturer to lay out the scope of what's allowed and what's in scope. Either to the entire community, you can broadly say, here's our bug bounty for anyone who wants to participate. Or of course, if you have a contractual relationship, setting out that scope of what's inbounds and out of bounds. Bug bounties in general give hackers what's called a safe harbor. So as you know, there's the Computer Fraud and Abuse Act and various laws that you can be charged with if you just go and try to hack something. Even if your intention is good, it doesn't really legally protect you because of unintended consequences that could happen. And so the best way to make sure that you're ethical and working with someone ethical and enabling only ethical hackers is to spend some time figuring out what are going to be the guardrails and then actually writing those down and advertising those to people.
Mm-hmm. Well, let's see. Before we scheduled this seminar, you and I had a bit of a tongue-in-cheek discussion over SBOMs, and I know you have this comic sort of pointing fun at SBOMs because you can, of course, create a trivial solution to delivering an SBOM. But the fact is, we need meaningful SBOMs by law for medical devices, and Section 524B of the Food, Drug, and Cosmetic Act is being amended and has been amended and does require manufacturers to submit not only SBOMs, but according to the final draft guidance, they have to also submit a list of any known vulnerabilities associated with those software modules, as well as what mitigation strategies they put in place to manage those risks. And so, setting the context, there's a question that as companies, including hospitals, are asking for documentation such as SBOMs and MDS2 forms, which, well, SBOMs are much more detailed. What are some of the issues to deal with in terms of, if a company's thinking, hey, is this going to enable a hacker to gain more meaningful insight into attacking the system? Or is it better that we just not put our heads in the sand? Is it better to have this information more widely available because of the long term having more resilience? Using the term from the PCAST report from the Biden administration's working group. But what are some of your thoughts on the dual-edged sword of SBOMs, or is it even dual-edged, or is it zero-edged? What are some of your opinions on SBOMs here?
I think that the SBOMs, and I'm going to actually group in two things. So there's the software bill of materials. This is the list of ingredients in your software. And specifically, it's the list of third-party components, right? It's the things that you didn't write that would go into this. And then there's something called software component analysis. That's the set of technology that ascribes vulnerabilities to that SBOM. And usually we lump those together inside the DoD, but commercially those are considered separate products. I think that they're important, but you have to understand where the limitation is. And so you have to not be naive about the policy. Requiring people to submit them is good. But here's a couple limitations. So first, the places that you're going to have an SBOM are typically going to be around open source components you use. And that's, especially when you're looking at vulnerabilities, that's what's going to be ascribed to them. And the reason for that is quite simple. You're not going to get CVEs for a lot of closed source stuff because people haven't looked at it that much. And so really, when you're looking at the utility SBOM and SCA, you're talking about open source stuff, which also means it's going to be of high utility at like level 1 certification. But when you're looking at like level 4, where software of unknown provenance means you're using something like a VxWorks, it's going to be less useful, I think. But that's not really kind of my tongue-in-cheek issue with it. My problem with the SBOM is there's a bit of a race to the bottom to put as many results into the SBOM as possible. Like, people will evaluate SBOM tool 1 is better than 2 if it can find more problems. And that can create a race to the bottom to just say everything is a problem. And that's been frustrating for me. And so I think the real thing that we should be looking at is what are the things that are actually used at runtime in the SBOM, not the overall package. So if the software doesn't run, it's not really on the attack surface.
So you're basically proposing sort of the analog to static and dynamic analysis, but in terms of SBOM?
I'm saying yes. You can give people a static SBOM, but really it's the runtime components. The other thing that we have to recognize, again, I've never known attackers using SBOM for this stuff, but the important part that I was going to say is looking at why people do not update dependencies. And they do that for reliability reasons. If you have 100 open source components in the display of your cool CT scan machine, all of a sudden you could start following the head development of 100 different open source projects. And that's no way to make something stable. And so there is a bit of it's not just simply, hey, it's vulnerable, so you have to update it. A lot of times those vulnerabilities may not be on the attack surface, or they may not be reachable for that particular piece of software. Like OpenSSL may have, Russian crypto is vulnerable. And if you're not using Russian crypto, you can still use OpenSSL safely. And the third thing is just be mindful of developers when they're trying to solve these problems. It's not a simple just like update like you would as a consumer. It requires a lot of time for the developer.
All right. Well, switching gears, as we have such a diverse audience, I want to get to a question from a biomedical engineer. So Hanan has a question about medical device manufacturers, why they might be hesitant to host some kind of public hackathon. Although we do have many who show up to the biohacking village at DEF CON, encouraging the hacking in sort of a pseudo-safe space. But the question posits that it may cost a lot to produce a proprietary health product. So what is the best way to encourage or convince medical device manufacturers that these hackathon sessions will still not invalidate their proprietary rights for their intellectual property or market share, but in fact enhance their product security. So what's some of the calculus that goes into holding like a hackathon for a medical device product? How does a company manage those risks? What should they be thinking about, and when do you know that they're ready to hold one?
Oh, I mean, that's a great question. So I think, there's the walk before you run approach here. And so typically before you hold like a public one, you're going to be engaging a smaller set of community. And that's actually a big step for a lot of people right now. A lot of medical device companies are started by physicians, biomedical researchers, but not security experts. And they get reports that things are safe, and they don't quite understand that doesn't necessarily mean they're secure. And so just starting by engaging consultants and looking at, hey, what are the techniques hackers use? Can we make sure those are part of our development process is important. And that's where, I talked about this thing that I've been working on, coming up with reference implementations. There's many ways that you can say you meet FDA guidelines, but not really be secure. Like the devil's in the details in a lot of this stuff. So I think engaging people on a small scale with trusted people is the first step. The second is when you start engaging a larger community, you are essentially making a PR calculus, but I can give you my perspective on this. About 10 years ago, I think it was. Same year, Target was hacked and Google was hacked. Hackers got into Target through the HVAC system. They ended up compromising credit machines, and this led to the CEO of Target getting sacked. Same year, Google got hacked by China. Huge email dumps of critical stuff, and everyone still thinks Google does security right. And I think the reason for that is because they've actively engaged the community. The community, when they find vulnerabilities, they're reporting a problem, but they're not saying you're insecure. Instead, I think when you do this, what you're telling the community is that we're open to that evaluation. That ends up building trust. And when we look at healthcare, trust, I think, is what you're trying to achieve. And so that's what I would recommend to people is, first start working with researchers, start working with vulnerability researchers, and start thinking about this more broadly. But then second, start weighing this not as negative public opinion, but instead, eventually we're going to get hacked. How do we make sure security research community doesn't have a bunch of I told you so's and sees you having made positive steps all along the journey?
And what's interesting about two of those entities you mentioned, Google not only got hacked by China, but they got hacked by the US government. Hopefully that's not happening anymore. But since you raised Target, so Bill is on the line as a co-moderator. I'm not sure what he can talk about, but he worked at Target. But Bill, we've got a good question here about what are some of the greatest vulnerabilities overall in medical devices, but maybe with your Target background, I'm not sure what you can even ask about, but be great to get into some of this space and how it relates to medical devices.
Well, I was the first security guy with that in my title at Target 100 years ago. And fortunately, I wasn't there at the time when that great hack happened. But that was really a matter of the complexity of the systems and not enough testing. But more importantly, it was more of an incident response thing where they had an indication that there was an issue, but the process to follow up on that indication of an issue just simply wasn't there. So it's certainly something that could happen anywhere and continues to happen, that sometimes it isn't about the vulnerability, the software or the product being terribly vulnerable. It's more about not following up on indications of trouble than anything else. I know that's true in healthcare as well. So, it isn't all, testing can't solve all the problems, but clearly it's a huge part of it. So that's about really all I can add about the Target piece, other than to say that I think everyone's vulnerable. And, we just talked about Google being vulnerable. There's really, you can't test enough. You can't have enough resources to make sure you solve all the problems. Actually, I have a question for you, David, for myself. At the very beginning, you talked about looking at the problem creatively, where you showed that maze where there's multiple solutions, and, even mentioned the fact just go around the maze entirely. I'm wondering about, as you begin the process and as you try to leverage this idea of taking creative approaches, Are there any exercises that you or you've seen used, maybe gaming exercises or any other kinds of ways of making sure that in fact you are looking at it from a completely different perspective? I mean, there are people that are intrinsically curious and that solves part of it, but I wonder if there are exercises that you're aware of that make sure that you're looking at all possible avenues for potential problems.
Yeah, I actually have pretty strong opinions here. So at Carnegie Mellon, we have the winningest DEF CON team ever. So DEF CON has the Super Bowl of hacking. We've won it 7 times, and our alumni are people like George, NSA, people like this. And so I think the way that we go about teaching this aligns with, there's a famous researcher named John Boyd who is actually looking into the nature of creativity. We don't try to say, here's a system and think of all the different possible ways to do it as a tabletop exercise with non-experts. Instead, what we start off with is a bunch of small problems where we give people, here's something that maybe looks secure, break it. And it's a very small thing. Like, here's a piece of crypto that's vulnerable to a timing attack. And this may be something that we just taught them. And we do this again and again with small problems, slowly building up the complexity. And so by the time you're looking at a real system, you have that background and that muscle memory of, here are the sorts of ways I should be thinking about it where a developer probably was not thinking about it. So I guess in a nutshell, it's example-based, but it's also part of destruction, if you will. You take something that's supposed to work and then you destroy it. And you want to do this in the smallest possible things as you build up that muscle memory. Giving people huge systems with a tabletop exercise is going to kind of be a waste of time, in my opinion. That's how we do it.
Got it. I also wanted to highlight a question from my friend Addie Stenica. I'll just read it to you. Pen testing each device coming into your organization is costly. What's your opinion to approach this subject for small and medium-sized businesses? From a cyber perspective, these are all great ideas, but from a business perspective, it might be realistic. So the key question is here, what is an incremental step that these small to mid-sized businesses can take to get started?
I mean, this was kind of the joke about the SBOM, how it actually can make small businesses, make it very hard for small businesses to do anything. So I feel the pain. I think, so I'm going to propose a radical solution here. And I don't, just because this is the FDA, I think what the FDA should be getting is proof of testing as opposed to process compliance. A lot of the requirements in automotive and FDA are, did you set up this expensive process as far as having a safety officer and all this? Instead, just from a pure, can you hack it? I would rather have something that said, give us your software in a digital twin, like something that I can run, and then show me that you've ran 1 million iterations of adversarial testing against it without finding a break. This is what many companies do when they get to that. There's another name for this. It's called really DevOps. I've avoided that name on purpose because I don't mean medical device manufacturers are going to develop software and field it the same day because these are online systems. Instead, what I mean is you lift up your software so that it's automatically testable. And then if people like the FDA required proof that it was tested, I think it would be easier for everyone. Instead, right now, you have to show proof of hiring a bunch of people.
Got it.
That's kind of mine. I think if you're small and you're working with the existing system, there is very much a small investment in developer productivity can often reduce cost and make security be improved.
Got it. I'm going to combine a couple of these questions and ask you, predominantly the conversation has been around as a manufacturer when you're designing product and doing your testing. So once a healthcare provider buys that product, and what have you seen in terms of them doing their own testing? And what are reasonable things that they can do, knowing that hospitals don't have the financial resources? But have you seen hospital systems that are doing testing of their own? And how can they do that effectively that actually adds value at low cost?
Oh man, I don't think I have. So what I've seen is I've seen some hospitals trying to fund device testing themselves. They quickly run into this problem that the devices are black boxes, and so they're trying to reverse engineer them. When if you could compel the manufacturers to go back and test it themselves, you'd be in a better place. That is a huge economic problem that I like no one else have a solution for. I think what hospitals, like the consumers of this, really have a huge stake in what sort of verification should be submitted to the FDA, and then also looking at this, not just pre-market, but ongoing market, how often was it updated? I think that we have to recognize that by the time that device is sold to a hospital, even if they find a problem, you got to go back to the company to get it fixed anyway. And so you can kind of prove it's unsafe, but I always look at security as the time from when a problem is identified to the time you roll out a patch, not just whether you found a problem. So you raise a really hard question, and I wish I had a better answer.
You know, healthcare providers are so limited in their resources and cost as well. So to find some incremental value to add there, and I'm sure is a real challenge. I wanted to talk to you also about your company, For All Secure, not so much to do a plug, although you're certainly welcome to do that. And, you know, I think, please spend a minute or two to talk about your organization, but you know, what kind of work are you doing there? What's the research there? And in fact, I know that I'm from Archimedes and that we actually help try to connect you with some other companies. So can you just talk about where you're headed there and what exciting things are coming up?
Yeah, so we spent 20 years at CME trying to figure out how the best hackers work. And then we built algorithms to automate it. Like this idea of this 3-step process, very simple, but we built sophisticated algorithms to do it. It was proven that we could fully automate both finding vulnerabilities and fixing them by DARPA. Now that's still a research organization. We built this thing called Mayhem, which won the Cyber Grand Challenge, which was even exhibited in the Smithsonian. So it was really big. What our company is doing is trying to bring that to market. And the reason for that is, as a researcher, I've seen many great ideas die trying to bridge this valley of death. And I figured, you know, if we're going to solve it, we have to put in the effort. And so what we've done is we've taken those same tools and we've tried to turn it into an enterprise system where people can adopt it as part of their software development lifecycle. And when you look at companies, I can talk about some of our companies, people like Rivian, for example, are using Mayhem as part of their software development, where they're running Mayhem as part of their software development before things are put out there. And really what Mayhem is doing is it's doing this adversarial testing. There is a lift. So when you have software, you have to lift it into the automated system so that it can then leverage the power of more compute power to do what George does. There's this tension in security where you can go hire a manual pen test and then it's done, versus invest in infrastructure that lifts it up so computers can do it. And we're very much believing that making computers do it is the right way. Regardless of whether you buy our product's called Mayhem. You can go to mayhem.security and look at it. The part that I was interested in talking about was the secure development pipeline. And how do you build this for medical device manufacturers? We have seen very insecure medical devices, especially when you expand the scope to like backend connectivity and API services that they may have. And so what I wanted to help build is a secure development pipeline, because when we go into these vendors, their problem isn't just what technology should I pick? Should I pick this or that for SBOM, this or that for SCA, this or that for dynamic analysis? It was, what does a pipeline look like where when you commit software, you get results out and then remediate it? Like how do we figure that out? Like you get an SBOM, do you have to fix everything or not? Is questions people ask about. How long should you do testing before it's safe to field? And that's what this is supposed to answer. And so I would ask, if people are interested in this and have medical device connections, that they reach out to us. This is something that actually ARPA-H funded, so there isn't, you know, HHS connection, with the hope that it would be more broadly applicable to people who are trying to get things certified both pre-market and in-market.
Very good. I wanted to field one more question and then wrap up with a few comments. This is one that was just added. There are security tools available for standard communication interfaces like Ethernet, Wi-Fi, Bluetooth, but embedded devices are a particular challenge because their communication interfaces sometimes are the same, but sometimes they're quite different and proprietary. So how do you approach security testing for those unique situations that are really true of embedded devices and particularly medical devices?
Oh, it depends what role we have. So let's say a weapon system falls off the back of a truck, very high value target. We're going to spend a lot of resources to get it inside the automated algorithms to go find 0 days. There's no magic bullet. You put in human time to try to then make it amenable for computer analysis. Think of it as a weird communication protocol. You may go and do binary editing and build special harnesses to get it. Very expensive to do. Again, go to automotive just because it's a great parallel when you look at these things. It's much cheaper if you're a manufacturer to stub out that functionality. When you're doing your unit and functionality tests, you're doing software in the loop testing. You don't need those weird protocols. In fact, if you go into MATLAB, you can say compile for Linux and give it a network interface that's Ethernet to make testing easier, even though eventually it's going to be on, I don't know, for automotive, it's the CAN bus or some different final architecture. And so one of the things that I would mention here, especially for device manufacturers, is sometimes they get wrapped up in, well, we have to do everything exactly as how it will be on the final device. That's not true. You need to be able to do testing on the final device, but you can build harnesses and testing methodology that's using software in the loop such that you're just replaying it over the real device, but the actual analysis is done on something far easier. That really is the solution. Otherwise, people are looking for a magic bullet. There's nothing out there that's just going to immediately take in all the weird protocols people have and be able to use advanced AI to go find 0 days. But if you do a little bit of work, harness it, so you can lift it up into that automated infrastructure, it unlocks a lot.
Great. Well, the final thing we wanted to talk about before we wrap up here is something that's coming up in a couple of weeks. For those of you that don't know, I'm the managing director of the Archimedes Center for Healthcare and Medical Device Security that Kevin mentioned. He's the founder of it. It's an organization for healthcare providers, device manufacturers, regulators, researchers like David, all to get together and have a continuing conversation. We have a big event coming up the week of starting April 30th through May 2nd, that middle of that week in New Orleans. That is our annual Archimedes workshop and some training sessions on the 30th, and then a 2-day workshop. And we're lucky enough to have David speaking at that event as well in a similar conversation. David, if you could just give us a few sentences on what you think you'll be covering and what are you looking forward to for this event?
I love in-person events because you get to connect with people, and I'm always a big fan of the hallway track. People talk about sessions like mine, but I find the most value after you give a session just connecting with people, and so that's what I'm looking forward to. What I'm going to be talking about is how do you hack things? Because I think this is something that, you know, I can provide value to the community by saying, like, if I wanted to go hack it, what would I do? Or when people employ me to go do this, how do I do it? And we'll be having a conversation similar to this.
It's great. We're looking forward to seeing you there. I just posted on the chat an email address, archimedes@northeastern.edu, if you want more information about Archimedes or the event, and also secure-medicine.org is our website. If you have interest in being part of Archimedes, the event itself, or anything else that I can help you with, I'd love to hear from you. And with that, I believe our time is up. David, we want to thank you so very much. Great discussion. Some new perspectives on things, liked your creative ideas. Thank you all for joining. We'll be having more CERC events down the road, and as most of you already know where to find it on the website. So thank you, and enjoy the rest of your day, everybody. Bye now.